Hello everyone, welcome you all in this course titled Digital Logic and Circuit Simulation. In today's lecture, we will discuss about another code converter that is named as BCD to Access3 code converter, and its vice versa means Access3 code to binary code converter. Let us take a what is BCD code? Generally, BCD code is used to represent a decimal number 0 to 9 in a 8421 pattern, and here the BCD is taken as an input and we generate a access3 code. Access3 code means B add simply, suppose the BCD is written BCD of any number like as a 0 0 0, and B simply add a 3 in BCD, and we will find what is here, that is 0 0 1 1. This means B add 3 in BCD, we will get a access3 code. That is why it is named as a access3 code. Here what happens here, this is the BCD representation of 0, means that are the input, BCD bits are taken as a, this is a input, and here the access3 code are, that is the output. So, this is also a 4-bit access code, and access codes means when BCD of 0 that is written in a group of 4 bit 0 0 0, what will be the output, that is equivalent to 0 0 0 plus 3 is added here, that is 0 0 1 1. Similarly, for BCD of 1 that is written as 0 0 1 plus 3 is added, this means this is 0 1 0 0, that is a 4. So, this means simply this is the access3 of 1. Similarly, access3 code of 2 is what, the binary code equivalent to a 5 like as a 0 1 0 1, and in this way we will write, but here we know the BCD code only from 0 to 9, and when we simply find the access3 code of 9, simply BCD first we write the BCD of 9, that is 1 0 0 1, and here another is we add 3 here in BCD form 0 0 1 1. This means when we add this, this is what, 1 1 0 0, that is the 12. So, this representation is 1 1 0. So, here we know that BCD is a weighted code corresponding to each bit position. There is a positional weight, means it follow a positional weight principle, but access3 is a unweighted code, or that is also a non-weighted code. There is no weight corresponding to any of the positional bit. Simply for add, B add, for representing a access3 equivalent of any BCD code, we simply add BCD 3 in that BCD representation, we will find the access3 code. Now, how we obtain the expression for access3 code output? Here the access3 code output are W, X, Y, Z, and here we also, this is a one important point, that is what, we not know the BCD representation from 10 to 15. This means whatever the BCD for 10 to 15, here the 10 is written as this 1 0 1 0, but what is here, that is, this is we not know the BCD of access3 code of 10. Similarly, there is no, because the BCD of 10 is different from, it means in these particular combination, in a BCD only these combination are used, and rest of the combination are not used in BCD. Similarly, we not obtain a access3 equivalent of these in this particular combination. So, all these are represented as X X X, means that is a don't care. Here K-map to design the logical circuit for conversion of BCD to access3 code. Here we see that what is the W, W is represented as what, output W in access3 code, W in terms of A, comma V, comma C, comma D. Here this is written as what, here W is in what input combination, means the combination corresponding to 5, 6, 7, 8 and 9. This is nothing but a 5, 6, 7, 8 and 9. In these particular combination, the W output of access3 code is 1, and rest means like as a rest are 0, and some output combination like as a 10 to 15, that is don't care. Don't care in summation 10, 11, 12, 13, 14 and 15. In these particular combination, the output we not means the what is the value of that output, that is X, means we not clearly know the value of whether the value of that particular output is 0 or 1. Similarly, what W or W is another is output is what, X of A B C D, which is written as summation of, here in what position, in what BCD code the output X is 1, here the BCD code equivalent to 1, 2, 3 and 4, this is written as 1, 2, 3, 4, 1, 2, 3, 4 and then that is 9, 9 plus this is a don't care is what, summation of 10 to 10, 11, 12, 13, 14 and 15. Similarly, we write the output y in terms of w in terms of a comma b comma c comma d, that is written as what, this is summation of y is 1 when 0, this is 1 2 3 4, 0 3 4 3 4, then 5 6 7 8, 7 and 8, 7 comma 8 plus don't care in the combination starting from 10, 11, 12, 13, 14 and 15. Similarly, Z output of VCD is written as Z in terms of A, B, C, D is written as what, here we directly derive in from truth table this what input combination, that is a 0, this is 0 min terms 1, then 3, 5, 0, 1, sorry 0, 1 is 0, 2, 0, 2, then 4, 6, 6 and that is 8 and rest of the combination plus don't care conditions, don't care min terms are 10, 11, 12, 13, 14 and 15. In this way we will write a Boolean expression for the output of XS3 code W, X, Y and Z, and after that we design a K-mat and find a minimized Boolean function or simplified Boolean function for each of the XS3 code output. Here we know that generally 10 to 15, this means that represents a 10, 10 means 10, 11, 12, 13, 14 and 15 that are don't care condition in each of the output representation. And here we see that when we write a Z, Z is what, for writing a Z, this is nothing but a Z is written as what, this is a 0, 2, 4, 6 and 8. So here this is 0, this is 0, 0, 0, this means 2, 0, 2, 4, 6 and that is 8. These are 1. And now our objective is to, in case some of the cells value is X means don't condition, B take it in a group when B form a group size that is a larger group size, and our objective is to make large adjacent square groups. So when some X is included in that group, then these X values are treated as 1, otherwise the X value is treated as 0. So when we find a group here, then we see that here there are two these square 0 0 and 1 0, only single bit is changed, means including X we take a group of 8 squares and that is taken as a single, and this represents what, whatever the value of AB in this cell C and D 0 0 1 0 means the value of D is fixed, this means Z is represented like as a D complement. Similarly, we will find the K map for, this is what, this is a K map for output Z. Similarly, we will find a K map for output Y. What is the K map for Y in combination, in what input combination? The Y is 1 in 0, 3, 5, 0, 3, 4, 7 and 8 and rest 10 to 15 that are don't care. Here simply we put all those value here. Here this is 0, 3, 0, 3, 4 and this is written as, here this is written as 0, 3, 4, 7, that is 0 is here, 3 is here, 4 is here, 7 is here and then the last one is 8 is here, and rest are don't care and rest are 0 like as a 0, this is 0, this is 0, this is 0, this is 0. Our objective is to find the large square group. So when we see that here there is maximum 4 squares are grouped together, here these 4 square groups and these 4 including some X are grouped together, and then we write a value. Here these two are not adjacent, we cannot make a group of 8 square. Why? Because here this is 0 0, this is 1 1, both bits are differ, that is why this square corresponding all these square corresponding to column 0 0 and 1 1 are not adjacent. Here this is a one group and this one is another group, and this group is represented by what? C complement D complement, and this group is represented by C into D. This means we can write the Boolean function for y in SOP form, that is CD plus C complement D complement, and similarly we will derive the expression for Boolean expression for simplified Boolean expression for output x, and here we see that what is the output x? X is 1 in the combination 1, 2, 3, 4 and 9, and rest 10 to 15 I do not care, and rest 0. So, here this is 1, 2, 3, 4 and 9 are written here, then we simply form a group. So, here when we form a group, this is a one of the group, these 2 squares and 2 squares are adjacent. So, this group represents what value here? What is the value of AB? 0 0 and 1 0, this means which one is fixed? That is a B complement is fixed, B is fixed, B, the value of B is 0, and here in CD 1 1 1 0 means the value of C is fixed, that means this represents a B complement C. Then another group, this we also group these 2 square and these 2 square, and this represents what? This group represents what value here? That is 0 0 1 0, this means the value of B is fixed, B complement, and what 0 1 1 0, this means here these 2 squares 0 1 1 1, that means here the value of D is fixed, that is B complement D. Similarly, next is another B, this is a only group of 2 square, and this group represents the value what here? The value of C is and D is fixed, and the value of here B is fixed, this means B C complement D complement. This means the whole the value x is written as what? B complement C plus B complement D plus B into C complement into D complement. Similarly, we design similarly we will find a Boolean expression or simplified Boolean expression in SOP form for a output W, and here W, when we see that the expression for W is written as 1 2 3 4, or W is written as 5 6 7 8 9. So, this is nothing 5 0 1 0 1 5, then 6, then 7, then 8, then 9, and here we will form a group of 8, these two, this square and this square are adjacent. So, one group is a group of 8 square, and this is represented by what? This is represented by A. Then another, these one are not grouped here. So, when we make, then this we make a group of 4 square, another group, and this group represents the value what? Here what is the value? 0 1 1 1 means the value of B is fixed, that is written as here B, here 1 1 1 0 means the value of C is fixed, this represents a BC. Similarly, this is another, and we make another 4 square group, and this group is named as this, these 4 squares are grouped together, and this represents what? This represents whatever the value, this is 0 1 1 1, this means the value of B is fixed here, and in this 0 1 1 1 means this means the value of D is fixed. So, this is nothing but a plus BC, this is A plus BC plus BD, and then we design a logic circuit diagram of XS3 BCD to XS3 code converter. And when we design a logic circuit diagram, simply for designing a logic circuit diagram, we take here designing a logic circuit diagram, W is written as, we simply write a W is equal to A plus BC plus BD, and then another X is written as, X is equal to, X is written as, we have to, X is what? B complement C plus B complement D, B complement C plus B complement D plus B C complement D complement, D complement. Similarly, log Y is written as C D plus C complement D, Y is written as C D plus C complement D complement, and Z is written as D complement. Z is written as what? That is D complement. This is also a D. So, here this is nothing but a what? C XOR D. This means here we will write, when we design a circuit, this is what? A, this is A complement. Similarly, B, this represents a B complement, Similarly, C, this represents a C complement. Similarly, D, and this represents a D complement. Then for representing our value W, W is what? A is taken from here, A is taken from here, plus BC, BC is taken from here, B is taken from here, C is taken from here, both are connected through a AND gate. This is a BC, and then another one is what? BD, B is taken from here, D is taken from here, and both are connected through a AND gate. This is a BD, and all three are connected by using a OR gate. This represents the output W. Similarly, for output X, X is what? B complement C, B complement is taken from here, this is a B complement, C is taken from here, this is a C. Simply both are connected through AND gate. Another term is B complement D, B complement is taken from here, B complement is taken from here, and this is D, D is taken from here. Then again both are connected through a AND gate. The another term is B, C complement, D complement. Simply C complement and D complement, B into C complement, D complement, B is taken from here, B is taken from here, C complement is taken from here, and D complement is taken from here. All are connected through a AND gate, and then all three outputs are connected through a XOR gate. This represents the value of X. Similarly, for representing a value, this is nothing but a C XOR D, C XOR D. Here C is taken from here, D is taken from here, and both are connected through a XOR gate. This represents a value Y, and similarly for representing a value Z, Z is nothing but a D complement. Simply here this directly goes, Z complement directly goes, this represents a output Z. So this is the logic diagram or logic circuit of BCD to access 3-code converter. What is the value? Suppose the value of A, B, C are 0, 0, 0, 0. What will be the output? W, X, Y, Z. Here what will be the output? What will be the value of W? Here what is the value of A? A 0 means this particular term is 0. Here what is BC? Both are 0, 0, that is 0. Then BD, this is a BD, that is also 0. What will be the value of W? W is, means all the input of X, R gate are 0, 0, 0, this means W is also 0. What is the value of X here? B complement C, here B complement C, C is 0, this means this particular input is 0. Here D is 0, this means this input is 0. This is here B is also 0, this means this input is also 0, this means the value of X is also 0. What happens here? Y, value of Y is what? What is C XOR D? Simply the C XOR, sorry, this is not a C XOR D, this is a C XOR D. C XOR D, this means the value of Y is 1. And what is Z? Z is D complement, D is 0, this means this complement Z is also 1. So what is the binary code? BCD code is 0, 0, then what is the XS3 code? That is written as W, X, Y, Z, which is 0, 0, 1, 1. This is the, so this is clear, this is the output according to the this table. This means the circuit, this circuit converts the BCD code into equivalent XS3 code. Next one is the vice versa condition, means suppose the XS3 code is given, then how we convert it into a BCD code. Here what are the, simply write a decimal number and XS3 code. XS3 code is, suppose the XS3 code value are 0, 0, 0, then we do not know the, when the XS3 code is 0, 0, all the bits are 0, 0, we do not know the corresponding BCD code. When XS3 code is means the bit value of XS3 code are 0, 0, 0, 1, we do not know, means all are do not care condition. Similarly 0, 0, 1, 0, we do not know the XS3. For XS3 converting a BCD code from XS3 code, if we know the XS code, simply XS3 code, the suppose XS3 code is what? 0, 0, 1, 1, and then we simply subtract 0, 0, 1 1 from that, this means that it's what 0 0 0 0. This is what, this is a BCD equivalent of given access code. Similarly, for finding the, suppose the access 3 code is what 1 0 0 1, then find a BCD code that simply we subtract what 0 0 1 1, we subtract 3, what we have to get, this is 1 1, that is 0, 1 minus 1 0, this is again 2 minus 1, that is 1, and this is what 1 minus 0, that is 1, because here subtractor is required, and this is 0, this is a BCD of decimal number 6. In this way we will find here when the all the 4 bit of access 3 code are 0 0 0, what is the corresponding BCD code, don't care, means all the BCD code bit position are don't care. Similarly, for when all access 3 code value is 0 0 0 1, then don't care, 0 0 1 0, that is don't care, and when the values are 0 0 1 1, then simply we subtract here 0 0 1 1 minus 0 0 1 1, then what happens, that is 0 0 0, we get a, here this is the BCD code for 4 minus 3, that is 1, this is a 1. Similarly, 5 minus 3, that is 2, this is 2. Similarly, 6 minus 3, that is 3. Similarly, 7 minus 3, that is 4. This is what 8 minus 3, that is 5. Similarly, 9 minus 3, that is 9 minus 3, that is 6. Similarly, here that is 10 minus 3, that is 7. Similarly, this is the access 3, when access 3 code value is 1 0 1 1 means 11, 11 minus 3, that means 8, and similarly when this is 12, then this is 9, and when the values are 1 1 1 1 0 1, and then we subtract what, suppose we subtract 0 0 1 1, what we get as the answer, that is 1 minus 1 0, then 2 minus 1, this is what 2 minus 1, this is 1, and this is what, this is 0, and this is again 1. Here we see that this is not a BCD equivalent of any, this is not a decimal equivalent of any BCD number, this means this is an invalid code. In that situation, all the BCD codes are, when the access 3 code is 1 1 0 1 1 1 1 0 1 1, again the BCD equivalent are don't care condition, then we simply get design a K-map, and then we get here for writing a Boolean expression for BCD output A. These are the access 3 code is the input, and this is what, this is the output. This is the output. When we simply convert input into output, we find the expression for output. Output A is written in terms of W, X, Y, Z. This is what, in what min terms the output is 1. There we see that when we write a output A, this is min terms corresponding to what, this is 1 and 1 corresponding to 11 and 12, this is 1 11 and 12, this is 1, what combination, that don't care, min terms are don't care, in a combination that is 0 1 and 2, this is 0 1 and 2. Similarly, 0 1 and 2, and then what combination, this is a don't care, that is 13 14 and 15, 13 14 and 15. In this particular min term combination, the output is what, the output is don't care. In this particular min terms combination, the output is 1, and rest of the min term combination, the output is 0. When we design a K map, then what happens here, here the K map is, when we design a K map, then simply K map, simply we design a K map for A, and then in a similar way you can also design a K map for B, C and D, and write get these expression. What is here, that is written as, generally these are the expression that is wrongly written here, this is nothing but a, not a W, this is A, and this is written as what, this is W X plus W Y Z. what happens, we will find the expression for A in terms of W x y z. Here this is a 4 cross 4 K map. Four cross 4 K map. This represents what? W x y and z, 0 0 0 1 1 0 1 1 and 1 0. Similarly, this is 0 0 0 1 1 1 1 0. Here we write a one extra term here, simply we delete it. This is 0 0, this is 0 1, this represents a 1 0 1 and this represents a 1 0. What happens here? In 11 and 12, that is 1 11, that is 11 means 1 0 1 1, that is 11, this is 1, 12 means this is 1 and rest 0 1 2 0 1 and 2, this is x, this is x and this is x. Similarly 13 14 15, 13 means this x, this is x, this is x. When we find a equivalent expression, then what is the expression? Here we simply make a group. When we make a group, then this particular group, this is a one group because we include the square in a group whose values are 1 or x for forming a large group, large square number group. This represents what? This represents nothing but a what? This is what? A and B, means this is W into x. Another group is what? When this and this we make form a only group of two squares. So this represents what value? This is what? This is fixed, means y z is fixed, and what is here? This is 1 1 1 0 means the value of W is fixed. This is W, y and z. This means the expression for A is what? W x plus W y z. Similarly, after making a K group for B, we will find a expression, Boolean expression, simplified Boolean expression for B, that is this, and then Boolean expression for C, that is written as y complement z plus y z complement, and for D, that is a z complement. Here we simply understand what is the D. Here we see that D, in case of D, here what is D? Here z is 1, here z is 0, here z is 0, here z is 1, here 1 0. This means this D is nothing but a z complement. After finding a simplified function for all the output variables of BCD code, then we implement access 3 to BCD code conversion. Here when we simply here find, let us design a circuit diagram for it. The circuit diagram is circuit diagram for access 3 code to BCD code converter. Circuit diagram for access 3 code to BCD code converter. Here circuit diagram, here what is the output? Outputs are written as Z is written as what? Z is simply here we see the output, that is D is written as Z complement. Here see D is written as Z complement. Then A, here A is written as what? Wx plus Wyz. Similarly, B output is written as, we simply see here B is written as x complement y complement plus x complement z complement, x complement y complement plus x complement z complement plus xyz, and similarly the output C means BCD output C is written as y complement z plus yz complement. This is y complement z plus y z complement. This is nothing y z complement, and this is nothing but a what? This is written as y xr z. When we design a circuit, this is what? This, suppose this is this is what? This is W, then this is W complement. Similarly, this is x. This is when we complemented it, this represents a x complement. Similarly, y, this is y complement, similarly z, and this is z complement. Then what happens, first term output is A is equal to Wx, W is taken from here, W is taken from here, X is taken from here, W, X, X is taken from here, then both are connected by using a AND gate, this represents a Wx. Another term is what, Wyz, this W is taken from here, W is taken from here, Y is taken from here, and Z is taken from here, that is W, Y, Z, all are connected through a AND gate. This is a, and when these two outputs are connected by using a single 2 input OR gate, that represents the output A. Similarly, what happens here, when we will find the value of output B, X complement, Y complement, here X complement is taken from here, Y complement is taken from here, and both are connected through a AND gate. Next is what, X complement, Z complement, X complement is taken from here, Z complement is taken from here, both are connected through a AND gate. Then X, Y, Z, X is taken from here, Y is taken from here, Z is taken from here, and then all are connected through AND gate, and then all three outputs are connected by using a XOR gate. Means when either this particular term or this term is 1, then the output is 1, and this is represented by B. Similarly, C is represented by Y XOR Z, Y is taken as here, Y is taken from here, Z is taken from here, and both are combined by using a XOR gate. This is what, this represents a C, and Z directly take the value of Z, this represents a D, Z complement. This represents, this is circuit diagram behaves like as a circuit diagram for XS3 code to BCD code converter, and let us check what are the out. Suppose the input value of W, X, Y, Z means when the XS3 is 0, 0, 0, 0, what will be the output? This term is what? First term is Wx, means this is 0, second term is Wyz, all are 0, 0, this means this is 0, what will be the value of A? That is 0. What is X complement, Y complement? Here X is 0, Y is 0, this means first term X, this is 1, and when any one of the input is 1, this means that is 1. What happens here? Third input, third is here Y complement Z and YZ complement, all are 0, 0 means this is also 0, and D is the Z complement, that is 1. So here we will find that when the XS3 code is, this is a XS3 code input, or XS3 code inputs are 0, 0, we will find that the BCD is what? BCD output is what? That is 0, ABCD form is 0, 1, 0, 1, 0, 1, 0, 1. But here we see that in the table, when the input is 0, 0, 0, the output ABCD are do not care condition, means we not know the value of ABCD. This means this is a unpredictable condition, unpredictable. This means this particular input, the unpredictable outputs are there, is no fixed outputs are there. Similarly, we will check what happens when the XS3 code is, suppose this is 0, 0, 1, 1. Here suppose the values are what? We take the values that are, simply we take the values which are, suppose the values are 0, W is 0, X is 0, Y and Z are 1, 1. What will be the output A? Here the output is A is what? Here Wx both are 0, 0, Yz and W complement, this is a Wyz, W is 0, Yz are 1, 1 means this is what? 0. What is the value of B? X complement, Y complement. Here X complement, Y complement means here Y is 0, this means this is also 0. Second term X complement, Z complement, here this is the value of X is 0, and the another is Z complement, Z is 1, this means X complement is 1, but this is 0, this term is again 0. What is the term X, Y, Z? Here the value of x is 0, this means this term is also 0. What will be the output b? Means b is equal to 0. Similarly, what is the c? C is nothing but a y xrz, and what will be the value y xrz? Means that is also y 1 xr 1, that is c is also 0. What is the value of d? D is what? D is nothing but a z complement, and here z is 1, z complement is 0. Means when the XS3 code input is 0 on 1, we obtain the BCD output here. BCD output is what? That is 0 0 0 0. This is a correct. So this circuit behaves like as a circuit diagram of XS3 code to BCD code converter, and this is all over about a BCD to XS3 code converter and XS3 code to BCD converter. In the next class, we will discuss about how we convert BCD code through a 7 segment display LED display. We will discuss this in the next class. Thank you very much.